Hey, Math 1, this is the lesson for 3.2. You're pretty much going to see the exact same thing you saw in 3.1, but I'm really just trying to highlight those special cases and cases where maybe you would be compelled to say something like no solution or all real numbers when really you shouldn't be saying those things. So, first one. I've got this inequality with grouping symbols. I mean, this goes all the way back to chapter 1. Do we know how to get rid of grouping symbols and combine like terms when we see this going? So, distributive property says this negative needs to be with the 2x and it needs to be with this negative 6. The 7x remains as is. Minus 2x comes out of that. A minus 6 means it's plus 6. So hopefully you guys are like, yes, this is finally making sense to me. The greater than or equal to symbol stays. Here, the negative 18 isn't being applied only through addition. 5 times x, 5x. 5 times 3, positive means it's a positive 15. Now this is the part where you guys are thinking, hey, the commutative property means same side, same sign. So don't change the sign. It's going to be 7x minus 2x, 5x plus 6. And we're comparing that with the greater than or equal to symbol with same side, then you do the same sign of what you see. So negative 18 plus 15 is going to be negative 3. Now, the variables, the like terms, the constants with the constants, they are now on opposite sides. So you're going to use opposite signs. To get the negative 3 with the 6, I'm going to use the opposite sign to move it over. So I canceled on the left. Normally I try to get the variables on the left, so maybe that was a mistake. But actually, no, not really, because I'm canceling both the x's on the left and on the right completely, leaving me with 9 is greater than or equal to 0 as my final statement. So, when the x's drop out, or cancel out, it's a special case. No solution if it's a false statement. All real numbers if it's a true statement. So here's the question. Here's my last statement. Is 9 is greater than or equal to 0? Is that true or false? Last time I checked, 9 was bigger than 0. It's true. Which means your conclusion should be all real numbers. Yeah, this is kind of tricky now because when we solved equations in the previous chapter, it was always 0 equals 0 gives us the all real numbers. But now, you really got to pay attention to the sign, the direction of the inequality symbol, and whether or not it's reading us an actual true statement or a false statement. Let's try another one. Number 2, I see decimals. We can get rid of those decimals right away. By multiplying both sides of the inequality times 10. You can do that to an inequality, just like you could with an equation. So multiplying by 10 gives me 50x minus 62. Does multiplying by 10 flip this around? No. It's still greater than or equal to 60 and then plus 52x. Now, I've got like terms that are on opposite sides of the equation. So opposite sides means I'm going to do the opposite sign to move it over. So normally try to get the x's on the left. And if you get the x's on the left, you want to move the constants to the right. So move the opposite sign. All right. 50 minus 52 is negative 2x. I didn't divide by any negatives, so this is still going to be greater than or equal to 60 plus 60 is 120 with the 2 at the end. All right, now I continue as usual. Divide by negative 2. Now this is where you have to really pay attention. Dividing by negative 2 on both sides means I need to flip this around. I explained it on the 3.1 video. Now it's less than. So, is this a special case? No. Not a special case. So the solution is that. So don't call it all reals. Don't call it no solution. That's the solution. And here's how you'd graph it. I'd probably skip count by 60s, something like that. And I'd say it's a closed circle, so this is just a little graphing review, just to the left of 60. And then we would go this way on the number line. By the way, I never graphed number 1. How do you graph all real numbers? Let me scroll back up really quick. So number 2 is completely finished. Back to number 1. We had something like 9 is greater than or equal to 0, and we said all real numbers. How do you graph this? Well, what are all real numbers? All real numbers are all the points on the number line. So when somebody asks you to graph the solution set for all real numbers, here's what you do. You graph a number line, maybe put a few points on both sides, and then you basically just give a number line in which every single point is accounted for. There's no beginning, there's no end. That's it. If you're the kind of person who puts it above the number line, you could draw that too. It just spans the entire number line. That's how you graph all real numbers as a solution set. All right, to number 3. Why don't you guys try this one on your own? Pause the video. Give it a go. All right, let's see what you got. 8x plus 16 minus 3x. Hey, negative times a negative is a positive. is less than 35 plus 5x minus 7. That's what you have. That's what you should have on your first line. Second line is 8x minus 3x is 5x. Remember, same side, do the same sign of what you're already doing. 16 plus 12 is 28. Still less than. 35 minus 7 is a positive 28 plus 5x. Now this is normally where I would move the x's to the left, so minus 5x here, minus 5x here, to cancel it on the right-hand side. Then I move my constants to the right. So I canceled on the right, so I now cancel on the left. But that cancels again. 0 on the left, 0 on the right. Didn't divide by a negative, so it's still less than. The x's dropped out. This is a special case. So you just have to ask yourself, is that a true statement or is that a false statement? Is 0 less than 0? Well, no. 0 is equal to 0. That's false. That's a false statement. If it's false, then we say no solution. How do you graph no solution? It's the solution set that's completely empty. So I draw a number line, and what I do is I leave it empty. I put empty set above hand to just remind the reader that I intentionally left it empty. That's how you graph no solution. All right, I only have time for one more. Luckily, there's only one more on the nose. Oh boy, fractions. It's all right. We're going to get through this together. What happens when you see fractions? Well, don't worry too much. As long as we find a common denominator, I think we can find a similar approach as when we had to solve equations that look like this. So step 1, find a common denominator. 3, 2, and 4. Let's make 12 the common one. So something over 12, something over 12, something over 12. Still greater than. So I have to multiply this by 4, so you get 40. Multiply this by 6. The 6 adopts the negative. So I'm multiplying by negative 6. And then multiply this by 3. Can we still ditch the 12? Can we still ditch the common denominator? Answer? Yeah. Because the reason we could ditch it is because ditching it meant you could multiply both sides of the equation by that 12. You can still multiply both sides of the inequality by any number you want. So multiply both sides by 12 and it cancels them all out. So now we solve the equation 40, and now we can start to distribute Negative 6 times 2x is negative 12x. Negative 6 times 4 is negative 24. Still greater than, because we multiplied both sides by 12, not negative 12. Greater than 9x plus 15. All right, 40 minus 24 is a positive 16. Everything else remains the same. I'm running out of ink in all my markers here. All right, so 16 minus 12x, we are so close to being finished here. Let's move the x's to the left and move the constants to the right. All right, can you guys see that? Ah, shoot, sorry. So, same sign, add the two. Keep it negative. I didn't divide by any negatives yet, so keep it greater than. 15 minus 16 is negative 1. Awesome. Now divide by, alert, negative, negative. You're dividing by negatives on both sides. You gotta flip it, you gotta flip it. Make it less than now. So you've divided it so that it's x on the left. A negative divided by a negative is a positive 1/21. That's my solution. It's all the numbers that are smaller than 1 over 21, which, here's how you graph that. You'd use an open circle at this, an open circle at 1 over 21, which, you know what, I'm just going to say here's 0, here's 1, here's negative 1. 1 over 21 is really close to 0 on the right side. It's going to be an open circle, and it's going to be everything to the left of that. All right, so 17 minutes. Whew, I think that covers it. Just make sure you guys aren't just blindly putting no solution and all real numbers on these. I put a pretty healthy mix of them on this set. So good luck. Thanks for watching.